Hello everyone, welcome back to the Funway Coding channel. Today we'll be going through the computer architecture, which is topic 1 of paper 1 of computer GCSE OCR. So today we'll be going through the FDE cycle and the components and the functions of the CPU. So what is the FDE cycle? So this question is quite common in the first page of GCSE normally, and it comes up as a 4 mark question, and I've got a model 4 marker at the end to show. And let me just go through the 4 simple steps. FDE stands for fetch, decode, execute, and repeat. So fetch, the instruction is fetched, so the CPU will go to the address of the next instruction. The data and the instruction is fetched, the CPU will decode it, and then it will execute it. And repeat. So this repeat is very key. So in your answer, you must add repeat, because if you do not, there is 1 mark for repeat always. So remember, always have fetch, decode, execute, repeat. So let's dive into some components. We have the ALU. The ALU is the arithmetical logical unit, which is responsible for calculating arithmetical and logical calculations. So logical means like logic gates. We can have and, or, nor, zor, and then in arithmetical it'll be like addition, subtraction, multiplication, division, exponential, mod, stuff like that. Next, we have the CU. The CU is the control unit. It is the brain of the CPU. So you can say that it controls the activities of the FDE cycle, and that is very key for the CPU. Then we have cache. Cache is where the recently executed instructions are stored so that they can be accessed quickly and executed very quickly. And then registers. Registers have very small storage of data, but can execute instructions very fast and have the fastest execution in the computer. So let's talk about some registers that we have to know about. So we have to know about the PC, the accumulator, MAR, and MDR. The CIR is not needed, but it is a mark. It is in the mark scheme. You may want to say it if you're not. I like to talk about the CIR. It's a very easy one. So CIR is a current instruction register, and it stores the instruction that is executing. The PC is the program counter and stores the address of the next instruction to be executed by the CU. The accumulator will store the results of calculations. Let's say if after you have done some calculations, let's say 5 plus 4 equals 9. So 5 plus 4 has gone into ALU, and then the ALU will give you the result, and that result, let's say, is 9. 5 plus 4 is 9, will be stored in the accumulator. Then we have the MAR, which stores the address of the current instruction that is executing, and the MDR stores the data needed for the instruction to be executed. So here is this 4 marker, which is the model 4 marker that if you write this down, definite 4 marks. So the PC will hold the address of the next instruction, and this address is copied to the MAR, and the CU will fetch this instruction and the data from the address in the MAR, and it will decode this instruction. This instruction is stored in the CIR, and the CIR will the CU will decode the instruction stored in CIR, and using the data stored at the location in memory, which is stored in MDR, it will execute the instruction. And if there's need of ALU or any, let's say, for arithmetical calculations, then it'll use ALU and store an accumulator, and then the PC is incremented, and then the cycle repeats. The PC is incremented so that the next time it repeats, it does not go to the same address. It'll go to the address of the next instruction to be executed. And this is it for the first topic, and next time we will go through CPU performance and what are embedded systems. Bye. Thank you for watching.